Statistics Unit 6, Practice Quiz 1A. Melissaini works as an app designer for a mid-sized tech firm. She spends all day writing thousands of lines of code, which are compiled and committed at the end of the day. At the start of the next day, Melissaini's supervisor uses a random number generator to select 100 lines of her code at random to check for errors. So the population that we're looking at here are the thousands of lines of code, which she actually did, if we're going to be looked at the next day, in one particular day. So the population would be Melissaini's thousands of lines of code from yesterday. The sample are the 100 lines of code selected at random. And because it said they were selected at random, also with a random number generator, these were all selected randomly. The only type of random sample we've looked at right now is a simple random sample, otherwise known as an SRS. And a simple random sample is by design not supposed to create bias and not supposed to skew any of our results. Not by design. If the survey taker was going to have some errors, that would be a different issue, but for right now, the simple random sample shouldn't cause any problems. Number 2. Hari thinks that his Homeric economics teacher isn't doing a great job explaining how supply and demand worked in the 17th century BCE, so he decides to ask his fellow students their thoughts on how the class is going. Hari takes a day to stand outside the professor's office during his office hours. As the students leave the professor's office, Hari asks them whether they think that the professor is doing a good job teaching the course. So the population here actually ends up being anybody who might be in the professor's classes, not necessarily that one class, but if you really want to, the population is students who attend the office hours. And the sample is anybody that Hari ends up talking to. Now, while this might be sort of a systematic way of getting submissions, it's not really a random way to use it, or to get submissions. In this case, we're just doing something relatively easy for Hari. We are just standing outside and saying, hey, you, come talk to me about this professor for a minute, instead of going and finding all of the students who are actually in the class. So what sampling method here? This is actually a convenience sample. It was more convenient for Hari to be in one place and just make people come to him than it was for him to go look for people. So a convenience sample is not a great type of sample design. It ends up leaving people out. In this case, yeah, it will probably create some bias. Who comes to office hours? Extremes. People who have and want to maintain high grades or fix low grades tend to come to office hours. We don't get as many people in the middle. Some other problems that might end up happening. This is just everybody outside the professor's office. So these are all of the professor's teachers, regardless of the class. So some people who are interviewed might not be in the Homeric economics class. And that's number 2. Number 3, RJ is collecting data for the school paper on students' pets. They spend a day carefully numbering each of the 2,296 students in the school and selecting 8% of the student body to receive an email request to fill out the survey. 3 weeks later, nobody's actually filled it out. So RJ hastily makes 184 photocopies of his questions and gives them to the principal. And the principal requires the next 184 students who are walking onto campus to complete the survey. So the population that we're trying to draw from is all 2,296 students at RJ's school. The sample, actually, we tried to get a good sample of just 8%, but we didn't get it. What we ended up getting is the next 184 students to walk onto campus. That's still about 8%, but it wasn't randomly selected. And since it's the principal telling the people that they have to already do the survey, they don't really get to have a voluntary response. And we said it's not a random response, so that means that this one is also a convenience sample, because it's a little bit more convenient for me as the principal to stand outside and just hand out the survey to whoever shows up than it would be to go around to all of the people who didn't fill out the survey in the first place. And is this likely to create bias or skew the results? Yes, it is. Some of the problems that might arise, you only get people arriving more or less at a certain time. You don't necessarily get a representation of the whole student body. If they give this early in the day, then you don't get any of the late people. If they give this a little bit later in the day, you don't get any of the early people. So not everybody really has an equal chance of being included. Something like that. And the last one. Animal control often screens the animals it takes in for Lyme disease, which can be spread in juvenile ticks. Yesterday, 30 animals were brought in, and 5 of them need to be randomly selected to be screened for Lyme disease. We need to design a simple random sample to select 5 animals using a string of random numbers, starting to count on 0, 0. So this kind of gives away a few things. How many digits are we going to use? Well, we have to use 2 digits because 0, 0 has 2 digits into it. And then what numbers will be meaningful? Well, it kind of depends on how it doesn't really depend, but I need to number things out or find out how many numbers will cover everything starting from 0, 0 and then going up to the 30th number. Might be a little bit easier just to say I start counting here and 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, and 29. So the numbers that are actually meaningful for us, everything from 0, 0 up through 29. Now, your numbering system might be different from mine. That's okay. If you decided to go 0, 1, 2, 3, 4, counting from left to right, then the animals that we select will be different, but the numbers that we select in part B will actually still be the same. So we just need a random sample of 5 animals, looking at 2 digits at a time. 79, not helpful. Neither is 48. That's not meaningful. 59, that doesn't help us either. But 22 will be selected. 0, 0, we started counting on. 99 is out, so is 40. 15 looks good. 44, no. 73, no. 34, 33, 68, none of those. Animal number 27 is in the mix though, and so is animal number 5. And then, part C, just match from the list which numbers go with which animals, the way that I've got this set up. Number 22 is rabbit C. Number 00, skunk A. Number 15, the way I've got this is cat E. Number 27 would be dog D. And lastly, number 5, the way I've got this set up, cat B is number 5. And that is your solution set for the first practice quiz.